Here is another example problem from our derivative worksheet. And this is really the thing I want to do more practice of today with you, and that's these application problems. Problem 13 and problem 14 on here are application problems, and then you have another handout that you're going to get today that has 6 more application problems. All the application problems, even though they have different contexts, they work the same way. If we're looking for, and we'll do number 14, we'll do the hog problem. We're looking for W prime of 43. Okay, what is that going to be? W prime of 43 is going to be the rate of change of W. Okay, and so W in this case is weight in, and I'm going to write Y per X. Y per X. The units of Y per the units of X. So the units of Y, weight is in pounds. T, or I guess X technically, sort of, is in weeks. So whatever we get here is going to be pounds per week. You have to figure out, when you look at the function and you read the problem carefully, you have to figure out what the input number is representing. The X is your input. What are your inputs? And what are your outputs? In this function, we're putting in weeks and we're getting out a weight. So we are measuring, when we measure W prime of 43, the change in that weight in pounds per week at a specific X. So let me model that for you for this problem, and then hopefully you can use this as a tool, and then as we let you do more of these, you'll do a little bit, you'll feel a little bit more comfortable writing out the context part. I know that was probably the part that was super challenging for a lot of people in the last quiz, to the point where I knew we needed to talk about this some more. And luckily we've got more function models that we can use. All right, so here's a little messy here because I've written on it. So my W function is 10 plus 5t to the 2/3. And I need W prime of 43. So that means I need the derivative of the W function, and I need to plug in 43. Okay, so my W function, and this is why we're coming back to these applications. Now that we have different derivative techniques, we can look at different types of models and use those different techniques. This is another chain rule problem. W prime, 2/3, 10 plus 5t to the negative 1/3 times 5. Okay. This one was a chain rule. Okay. You know you're going to have to do chain rule when you have a quantity raised to a power. You may see chain rule mixed into other problems, like we looked at chain rule inside of quotient rule and chain rule inside of product rule. All right, now this one's a little messy computationally. Once again, I clearly wasn't worrying about making this nice, and I Actually, I don't know what I was thinking when I decided 43 was a good number. Who knows? Who knows? But that's what I put, and this one, I couldn't think of a better one to change it. I played around. I couldn't really come up with something that worked better. And really, it shouldn't matter. We can do the computations. We've got a calculator to do the computations, so they don't have to be nice. That's 2/3. That's 225 to the negative 1/3 times 5. So yeah, if we didn't have a calculator, the cube 1 over the cube root of 225 isn't something we can just pull out of a hat as a number, but my calculator can pull that out of a hat. And let me do, Desmos still up here? All right, okay, so how can we do that? How about 2/3, it'll be build the 2/3, and then I don't have to put it as a 1 over. I can do 225, and Desmos is perfectly fine if I do the caret, the little pointy arrow guy on the 6, negative 1/3. I used to use my fraction bar, my division sign, the slanty on the question mark, and then times something. Wait, I have my paper right here. Times another 5. And we get that number. Oops, and look, it even understands that I mean times 5 when I don't write times. So, but I can't write times. Times 5. So 0.548. Let's go 3 decimal places. Let's see now if we can talk about what that means. We got 0.548. I'm going to extend this down. Okay. So we got 0.548. So we're going to start by talking about that the rate of change of the weight, we can say the weight, how is it changing? It's increasing. If I get a positive number, whatever I'm measuring the change of is increasing. If I get a negative number, whatever I'm measuring the change of is decreasing. So the thing I'm measuring the change of, the change in the weight is increasing in, or by, maybe by, not a lot, because it's like, it's a little, if we kind of think about what's happening on this problem, we're putting the hog on a special diet, and in this case 43 represents 43 weeks. 43 weeks in, we're probably not going to be getting a super rate of gain. I'm willing to bet, and we could explore this if we wanted to see like what's w prime of 36 or w prime of 20. Probably this function is growing, but then the growth slows down. We could look at the graph and we could see that. So the weight is increasing by 0.548 pounds per week, because this is our y and this is what our x is in, at, or when we're at week 43. So 3 things. What's changing and how is it changing? The units, value per unit, and when is it happening? I'm going to ask you to practice this today with 6 other application problems. 2 of them have, I'm going to pull this up here to show you. Actually, you know what? Let's stop this one and then we'll talk about that worksheet on a 3rd video.